We're now ready to look at an example for the matched pairs or the paired t-test. We are looking at researchers who are interested in testing the effectiveness of a new diet. So they have 20 participants. These participants were measured their weight before a diet. They were on the diet for 1 month and then they weighed themselves again. We want to use the data below here to test the effectiveness, and we're going to use a matched pairs approach, and our alpha level, our significance level, is 0.05. What does it mean by matched pairs? With matched pairs, we are looking at data values that have a pair, or has a partner, if you will. So one participant here, the first participant, has 2 values associated with that person, a before and an after. If we look at each person has a before and after. Our hypothesis test is going to look at, and what's going to be important here, are the differences between the before and after. So we're going to look at the differences, and we're going to find that with the before and after. So this is not going to be required for you to do in every single example, but I think it's going to be helpful. Let's go through and look at the differences for each person. This should only take a minute because these numbers are small, or the differences are small. 180 minus 170. So I'm going to take the before and subtract the after, and I'm going to get all the differences. So some of these are more significant than others. And what I want you to think about is, relative to this problem, what is this value of the difference for each one of these? What does it represent? If we're subtracting the before weight, or we're taking the before weight and we're subtracting the after weight, what are we getting? The difference here is going to be the weight loss. So participant 1, using the diet, lost 3 pounds. Participant 7 lost 6 pounds. Looks like participant 10 and participant 16 actually gained a pound, where their weight afterwards was higher. So using these differences, we want to create our null and alternative hypothesis, and that's what the null and the alternative look at. We're not going to test that the difference is equal to 0. We're going to look at the mean difference. So if I were to add up all the differences here and divide by 20, I would have the mean difference. So in this case, the mean difference is the mean weight loss. Remember, the null hypothesis is still always going to be 0. It's equal to 0. There was no difference. The mean weight loss, if you will, in this example, is equal to 0. Versus if the diet was effective, meaning if I take the before and subtract after, what am I going to test this against? Well, if the diet is effective, the weight loss is going to be greater than 0. We don't want to do less than 0 because we're not testing then that the diet was effective. The only way for us to test whether or not it was effective or it's not is to look at the before minus the after and whether that was positive. That means if you have a positive number here, there was a mean weight loss greater than 0, then the diet was effective. So what I'm going to do is to put this information into statcrunch. You're going to notice that I've already gone ahead and put the data into statcrunch. I have the participant number, the before, and the after. If you need to, pause this video and get this data into statcrunch to follow along, please do. To calculate the p-value, we're going to go into stat, t-stats, and paired. Our sample 1 is going to be the before, and the sample 2 is going to be after. I'm going to save the differences. What statcrunch is going to do is, using this paired approach, they're going to calculate the differences. So if you click on Save Differences, it's going to create a column for the differences, which we already did. But now, using this, maybe we'll need that later. We might as well put that in a column. We're testing that the mean difference, if you add up all the differences and divide by 20, it's equal to 0. Versus the mean difference is greater than 0. So there was an average weight loss, right? There was a difference in the before and the after. We're not going to worry about the confidence interval. We're going to come back to that. So let's compute. When we compute this, what do we get? We get a before and after. We get the sample difference. So this is the mean difference here, the mean weight loss, the degrees of freedom, the standard error, the t-stat, and finally the p-value, 0.0003. So let's write that down. The p-value is 0.0003. Since this is less than our alpha level, which is 0.05, what are we going to do? We're going to reject. They're going to reject the null. So what's that saying? If we reject the null, there is evidence to support the alternative, meaning that the mean weight loss, the mean difference between before and after, was larger than 0. This is telling us that there was evidence to believe that the diet was effective versus that there was no weight loss at all. Now you can look at these values and determine whether it's practical if you want to go on this diet, right? But statistically speaking, it was more effective than just having the differences being equal to 0. Right? The mean difference was larger than 0. What is the average weight loss over the 1-month diet? And then we want to construct a 95% confidence interval for the mean difference. So when we construct a confidence interval, we're going to go through the same procedure here. We're going to go back to this. Now if you click on options and click on edit, you can actually get right back into where we were. We don't need to save the differences anymore. Calculate a confidence interval and compute. The sample difference, this is the mean difference. So let's write that down. The mean difference, and I'm going to write this, x bar difference, because we know it's not mu, that would be the population difference. The sample mean difference was equal to 1.6, this is how terrible my memory is, 1.65. Okay, I just needed to know that. That is the mean weight loss, essentially, for these participants. And the confidence interval is going to have a lower bound and an upper bound. So I'm going to round these, but the upper bound and lower bound. The lower bound is 0.81, and the upper bound is, let's say, approximately 2.5. So 0.81 and 2.5. 0.81 and 2.50. What is this telling us? This is telling us, let me make sure I got that. No, it'd be 2.49. Sorry. 2.49, even though theoretically it's not going to make much of a difference in our interpretation. What is the average weight loss over the 1-month diet? We got that, 1.65. And then we constructed a 95% confidence interval. This is telling us that on this diet, the average we would expect with 95% confidence that the average weight loss, average difference, will be between 0.81 and 2.49. Since 0 is not contained in this interval, that's telling us that there's evidence that the difference is positive, that the diet is effective. Although it may not be very effective, it's still statistically effective, meaning it's greater than 0. Notice we could have actually solved this problem differently by looking at all the befores versus all the afters. Right, using just a 2T test, looking at all the befores and all the afters, but instead, using a matched pairs approach, we looked at each individual person, the differences, and then the average of those differences. That's how this matched pairs approach is different than a regular sample or 2-sample t-test.